Hey everyone! Welcome back to Class Bites, your place for quick and easy lessons that make learning simple and fun. Hope that you liked our previous clip for What Shapes Our Planet's Climate. Today's topic is about to explain how plate tectonics influence the distribution of earthquakes and volcanoes around the world. Grab a few minutes and let's learn something new together.
The Earth's surface is not a single, unbroken layer of rock, but a vast, shifting mosaic of enormous slabs known as tectonic plates. These plates fit together like a jigsaw puzzle, covering the planet's outer shell called the lithosphere. Beneath them lies a softer, semi-molten region of the mantle that allows the plates to move very slowly over time. Their movement, although almost imperceptible to human eyes, is the driving force behind many of the planet's most powerful and dramatic natural events. The constant motion of these plates is responsible for shaping continents, forming mountains, and determining where earthquakes and volcanoes are most likely to occur. Earthquakes and volcanoes are not randomly scattered across the globe. Instead, they tend to cluster along the boundaries where tectonic plates meet. The reasons for this concentration lie in the ways these plates interact with one another. There are three main types of boundaries between plates, and each type produces different geological activity. Where plates move apart, where they slide past one another, or where they collide, stress and pressure accumulate in the rocks along these zones. When that stress is suddenly released, or when molten material from the Earth's interior finds a path upward, the result is an earthquake or a volcanic eruption. At divergent boundaries, tectonic plates move away from each other, creating deep cracks through which molten rock from the mantle rises. As this molten material, known as magma, cools and hardens, it forms new crust. These zones are often found on the ocean floor, creating long underwater mountain chains called mid-ocean ridges. Earthquakes here are generally less violent, but they are frequent, as the continuous movement of the plates keeps the crust under tension. Volcanic activity in these areas is also common, since the separation of the plates provides an easy route for magma to reach the surface. Over time, this process slowly expands the ocean basins and pushes the continents apart. In contrast, convergent boundaries occur where plates move toward one another. When an oceanic plate and a continental plate collide, the denser oceanic plate is forced downward into the mantle in a process known as subduction. As it sinks, the plate melts and forms magma, which can rise through the overlying crust to create volcanic arcs along the edges of continents. Many of the world's most explosive volcanoes are found in these zones, where immense pressure builds beneath the surface before being released in violent eruptions. The friction and compression between the plates also cause large, destructive earthquakes. When two continental plates collide instead, neither plate easily sinks into the mantle. Instead, the rocks crumple and fold, forming vast mountain ranges. In such regions, earthquakes are frequent because of the intense stress produced by the ongoing collision, but volcanoes are rare, since little magma reaches the surface. The third type of boundary, called a transform boundary, occurs where plates slide horizontally past one another. The edges of the plates are rough, and as they grind against each other, they often become locked due to friction. Over time, stress accumulates until the rocks suddenly slip, releasing energy in the form of an earthquake. Because there is no melting or creation of new crust at transform boundaries, volcanic activity is minimal or non-existent. These boundaries are typically marked by long, visible fault lines that cut through the crust, and they are among the most active earthquake zones on Earth. The overall pattern of earthquakes and volcanoes around the planet mirrors the edges of the tectonic plates. The most dramatic example of this is the so-called Ring of Fire, a belt that encircles much of the Pacific Ocean. This region experiences intense seismic and volcanic activity because it is bordered by numerous convergent and transform boundaries. The movement of the plates in this area creates subduction zones, deep ocean trenches, and volcanic island chains, making it one of the most geologically active regions on Earth. Other active zones can be found along the boundaries of the African, Eurasian, and American plates, where the interactions of these massive slabs of rock generate both earthquakes and volcanic eruptions. Even regions far from plate boundaries can experience earthquakes, though they are usually weaker. These occur because the stress from plate movements can be transmitted across the interior of plates, reactivating ancient faults buried deep within the crust. Similarly, volcanic activity sometimes happens away from plate boundaries when a column of unusually hot rock, called a mantle plume, rises from deep within the Earth. When the plume reaches the surface, it can form a hotspot volcano. Over time, as the plate moves across the stationary plume, a chain of volcanic islands may be formed, marking the path of the plate's motion. The continuous movement of tectonic plates is the fundamental mechanism behind the global distribution of earthquakes and volcanoes. Their interactions not only explain why certain areas of the world are so prone to natural disasters, but also reveal the dynamic and ever-changing nature of our planet. Through these processes, the Earth constantly reshapes itself, building new crust in some places while destroying it in others. Mountains rise, ocean floors spread, and continents drift, all as a result of forces deep within the planet that have been at work for millions of years. In essence, plate tectonics provide the framework for understanding why the Earth's surface looks and behaves the way it does. The boundaries between plates are zones of immense energy and transformation, where the planet's internal heat and motion express themselves through earthquakes and volcanoes. Without the slow but relentless movement of these plates, the Earth would be a far more static and lifeless world. Instead, their ceaseless shifting ensures that the surface remains alive, constantly evolving, and full of both danger and wonder.
That's it for today's Bite of Knowledge. If you enjoyed this video, let us know what you want to learn next down in the comments. And hey, hit that like button and subscribe to Class Bites so you can keep learning and improving a little every day.